guys, hope everyone's doing well. This is our first note sheet we're going to do. We're starting our new unit over rational expressions. So first of all, what is a rational expression? It's going to be a ratio, like a fraction. It's going to be made up of two polynomials, okay? We're going to start with simplifying rational expressions. So we're going to break them down so they have no common factors. Two things to keep in mind when we're doing these. You can always cancel factors that are common. You can never, ever cancel terms. Okay, so make sure you can see here the difference between terms and factors. So we have a polynomial. We know what those look like. You've got your terms broken up with addition or subtraction. Okay, you can have binomials, trinomials, four terms, and so on. So two terms can be broken up, right? Now notice here, two terms, when they're written, it's just two things being multiplied here or a single number. Factors are different because they're broken up by multiplication. Notice these factors are in the grouping symbols here. They have addition or they can have subtraction in between them. Okay, so we're going to start with our factoring. Down here and canceling. So when we look at our first polynomial, you can see we're going to factor it out. So we took out a GCF of 5 from the top and then factored the difference of squares. Same thing on the bottom, the two numbers that multiply to 10 and add to 7 were 2 and 5. So it's just been factored for you. We'll talk more about that when we get to it. And then when we look here, once it's in factored form, you look for common factors, numerator to denominator. So this one we were able to cross out x plus 2 from the top and from the bottom in common. And then you're left with 5 times x plus x minus 2, and on the bottom, x minus 5. All right, so let's try one. So the first thing we're going to do is we're going to reduce the factored form of this polynomial from the top and bottom that make up the rational expression. So when I look at it, we see we have a factor of 5 here, and I have a factor of x minus 10. In the denominator, it's already, we have one term, so we just want to see if we can take anything out of that. And so you should see we have a GCF here of 5. So we can take a 5 out of each one. We're going to divide it out when we say take it out. So 5 from 5 is 1. That one's gone. You get x minus 10. And then 5, we're going to divide 5 out of 50 to leave us with just 10x. So when you write your final answer, you can leave it with the parentheses or you can leave it. A lot of times you're going to see it, it will drop the parentheses and look just like that. All right, so the same thing here. We look, nothing has a GCF or anything that being taken out. We have our factors in the top, x plus 5. The other factor is x minus 10. In the bottom, we do have an x minus 10. Now remember, these are grouped together. I just added those parentheses to emphasize these two have to be connected together. You can't separate them. So when I look, though, I do have that common x minus 10. So we divide that out. All we have left is x plus 5. Since your denominator got divided out, it's 1, so it's gone. Same thing for part C. We have an x plus 5 on the top. Again, those are grouped together. We have an x plus 5 on the bottom. So we can factor that out, dividing it out of the problem. Now, in the numerator, if you divide it out, it becomes a 1. Okay, so it is still there. And then on the bottom, we're left with x minus 10. Okay, so I'm going to start here with D. I'm going to look again, no addition or subtraction, so we want to look for commonalities top to bottom in our numerator to denominator, anything that can be divided out. So I have a minus 5, a negative 5, excuse me, and a 50. So we can take a 5 out of each one of those. So if I take a 5 out, that's negative 1. You can write the 1 if you want, but normally you're not going to see it. 50 divided by 5 in the bottom is going to be 10. Now I've got 5 as my exponent on top and a 1 on the bottom, so we can get rid of 1. That's going to leave us with x to the 4th in the numerator, and a y to the 1st and y to the 1st, so those cancel, and there you go. Done. Now this, for part E, here's our top. Okay, we have an addition that's separating, so these two are connected. On the bottom, we have a multiplication. If you want, you can multiply this together and make it 50. You don't have to, but you can. What I want you to notice, though, is that these both have a common factor of 5. So you can rewrite that as 5 times x plus 2y. Oops. And then on the bottom, again, if you want to write it as a 50, you can, but you don't have to because it has that factor of 5 already out. But I'm going to rewrite it like this because that's typically how you're going to see it. I just multiplied together, rearrange that order of the multiplication. And now you can see the GCF of 5, top and bottom, common factor, can be reduced out. And that's just going to leave you then with the x plus 2y over 10xy. All right, and then our last one here, we have a GCF of 5 in the top that you want to take out from here, x plus 1. And then on the bottom, I'm just going to write here so we can see before we start to reduce, just write it out. And then you can see you have a common factor here, x plus 1 over x plus 1. So we can take those out, reduce them out because they're on the top and bottom, 5 over x plus 5. Okay, and that's how you want to reduce. So what I want you to do is pause the video now, try the 4 on the bottom, and then we're going to come back and talk about checking your answers and see if you did it right. All right, now that you've tried it, let's check your answers here. All right, so the first one you can see, they factored out terms, not factored parts. So what you want to do is look at the 5 and the 10 here, and notice we have a GCF. So you can rewrite this as 5x over 5 times the quantity x plus 2. Once you're here, you can see you have a common factor of 5 top and bottom that can be reduced out, so you end up with x over x plus 2. All right, let's see what we did wrong on the bottom here. So this one, when they reduced it, so they did factor the bottom. We're going to talk about this a little bit more on the back. This is the difference of squares. Remember how to factor those. X plus 3, x minus 3 is correct. We have x minus 3 on the top. Now, the common factor, though, when we take it out of the numerator, it becomes a 1. So 1 over x plus 3. So they didn't take the, that's in the numerator. And that's not allowed. It's supposed to be in the denominator. Okay, so here we have it factored. So the factor should have been, because this is a minus, it should be a minus and a minus. So this one actually doesn't have anything that you can reduce. It would just stay x minus 5, all over x plus 5, and there's no common factor, so you just leave it like that. Okay, so they factored wrong. All right, and then the last one here. So if you remember, if this is squared, that means it's written 2 times. Okay, when we take our GCF out here, let's see. Let's rewrite it first of all. So it's be 3, x plus 3 times x plus 3 over. Now we can take a 9 out. That is correct. And then we have our x plus 3 there. So we can take one group only of the x plus 3's out. Okay. And then when we simplify here, that does become a 3. So the final answer, you should have x plus 3 left in the numerator. And then only in the denominator, 3. Again, you cannot reduce those because those are terms. Okay, so let's go to part 2 on the back.